July 19th, 2021 was an interesting day. Wildfires in the USA West and Canada put smoke into the air, and that smoke was blown to the northeast, leading to air quality advisories and dimming the sun for several days. This video is how I estimate solar production from the Weather Underground website Weather History feature. This was the scene I woke up to on Tuesday, July 19th. Normally, at this hour of the day, the sun is too bright to look at, but this was orange and dim. The sun rays needed to filter through a vast quantity of fine particles in the air, and that dispersed the blue light, giving the sun a dull orange hue. This National Weather Service video from a geostationary satellite shows the smoke the next day on the 20th, still streaming over the USA Midwest. So if you have solar panels and you want to see how much energy you should have made, I'll show you one method to do it in this video. The reason to estimate energy production could be to see if there's degradation in an older solar panel array, for example. The first step is to go to the Weather Underground website. In the rightmost field, enter a zip code that you want to study. I select 43551 for Perrysburg, Ohio. Then I use the cursor and click on the city name. The screen that you see is a typical weather website with 10-day forecast and the map, but if you scroll down you'll see a table for nearby weather stations. I select the first one for Perrysburg. This page is one of my favorites. It shows data from somebody's personal weather station, and they share that data on the Weather Underground website. And the feature that's valuable is the local history that it has on the page. Not all weather stations have solar irradiance, but this one does. This map shows several other weather stations here, so if the one I selected was not equipped with a solar irradiance sensor, I could select a different one. Scrolling down on a website, there's a weather history section. Here's where I pick the days and the years that I want to study. I just pick daily mode, month, day, and then year, then select view. This chart shows solar radiation in watts per square meter and is from July 18th, 2020. My solar panel system produced 26 kilowatt hours on this day, and the peak sunshine lasted from 10 a.m. to 4 p.m., peaking at almost 900 watts per square meter. A very nice, clear, sunny day for me. So this is the baseline of known good performance that I'll compare to July 19th, 2021, when there was all the wildfire smoke. Here's a chart, but the date is selected to be July 19th, 2021. The curve of the solar radiation is the same, but it's lower, with a peak of just 660 watts per square meter. So how can I quantify how much power I should have made on this day, given that the peak radiation was less? A little lower on the page, on the left-hand side, there are two tabs. One says Chart, which is the default, and the other is Table, which needs to be selected. So after changing to the Table view and entering the day of interest, I get a table with 290 rows, and it has a data record every 5 minutes. I'll highlight all this data and press Ctrl-C to copy it to my clipboard. Then I open a new Google spreadsheet and paste that data in. Column letter L has a solar radiation data in it, but unfortunately there's also text in these fields that needs to be removed. So I click on one of the cells with the data I want, and I highlight the characters for watts per square meter. It also has a space in front of it, so highlight space W/M and then superscript 2. Then press Ctrl-C to put those characters into the clipboard. Next, highlight the entire column L, and then press the Ctrl-F key simultaneously. This should bring up a Find box. Then click on the 3 vertical dots to get more Find features, which is really just the Find and Replace window. So click on the empty Find field and press Ctrl-V simultaneously to put those characters into the Find box. Then leave the Replace box absolutely empty, and then press the Replace All button. This strips the text out of the data we're interested in. Now in column M, enter the formula 5 divided by 60 times L and its row number divided by 1000. This will convert each row of data into a piecewise integration of the solar energy curve. The 5/60 converts the time interval into hours, and dividing by 1000 converts watts to kilowatts. Then copy that cell from M4 to M291. If you want to create a chart of this, to make sure that the shape matches the PWS website, it should look a little bit like this. The blue area under the curve is the energy. Then in cell M1, enter the formula, which is the sum of cells M4 to M291. This adds up the total energy that was collected all day long in kilowatt hours per square meter. On this slide, I enter the 2 days that I'm comparing, July 18th, 2020 and also July 19th, 2021. I enter the summations for each day here. The next step is to scale the data for how many solar panels are being considered. I have utility-sized 72 cell panels with 6-inch square cells. So each panel has 1.7522 square meters of solar cells. That's not the outside size of the solar panel, it's the size of the cells in the solar panel. And I have 16 of them. So I multiply 7.1 kilowatts per square meter from July 18th by 28 square meters to get the total solar radiation that was shown onto the solar panels. The next step is how I account for the solar panel inefficiencies and other inefficiencies in the electric system. On my control day, July 18th, 20, I measured 26 kilowatt hours off of my solar power meter. So I multiply that total solar irradiation by 0.13 to get the same 26 kilowatt hours. This shows like a 13% efficiency from sunlight to AC. Then I use that same 13% and apply it to July 19th, 2021, and I see that I get 18.6 kilowatt hours. And then dividing these two together, I see that I lost 28% of the production due to this wildfire smoke. Thank you for watching, and I hope you learned how I estimate solar power production from the Personal Weather Service website data.